Okay, take a deep breath. Start simulation.
Good afternoon, I'm Cassidy.
I'm Kira.
And today we're going to do an experiment where we have three materials. So we have one clay that is shaped like a ball, another clay that is flat, and both of them are the same weight. And we also have a bucket that is full of water. So Emily, I really need you to listen to this question because I need to make sure that you can make a right prediction to what the question is, okay?
Okay.
So the question is, if I drop both the round clay ball and the flat clay piece into the water at the same time, what do you think will happen? So there are three choices that you guys can choose from. One of them is the two clay pieces will land at the bottom of the container at the same time. The clay ball will hit the bottom before the flattened piece will, and the flattened piece of clay will hit the bottom before the clay ball will. So I want you guys to think about that and think what you might think will happen. So raise your hand if you think the two clay pieces will land at the bottom of the container at the same time. Jayla, why do you think the two clay pieces will land at the bottom of the container at the same time?
Well, I think that they'll land at the same time because of gravity.
Okay, so you think that they will land at the same time because of gravity. Carlos, why do you think they will land at the same time?
Because if they're the same weight, then they would go the same time.
That's a good reason too. If they're the same weight, it would seem like maybe they will land at the bottom at the same time. So who thinks the clay ball will hit the bottom before the flattened piece will? Raise your hand. Mina, why do you think that?
So I think that the clay ball will hit before the flat one because the clay ball shape has less it won't pick up as much water, and I feel like the flat piece might pick up a lot of water and it might take a long time for it to get down.
Okay, so you think that the shape has something to do with which will go to the bottom first. Does anyone else think that is the second option? And then the third option is the flattened piece of clay will hit the bottom before the clay ball will. Raise your hand if you think it's that. Will. Why do you think that?
Well, I think that it will hit the bottom first because it's thinner, so I don't think it weighs as much.
Okay, just to let you know that they do weigh the same weight, but you do think since it's flat that it's possible that will hit the bottom first.
Yeah.
Okay, and then Emily, do you think it's the third option as well?
Yeah.
And why do you think that?
Well, I think that because it's flatter, it'll just work with the water better and it'll just go down quicker.
Okay, so you kind of agree with what Will said. So I want Mina, Will, and Jayla to talk together to see if you can change your mind on what you heard from everyone's answers. And I want Emily and Carlos, I want you two to talk together and see if something changes of what someone said. And then Kira will ask what your second prediction is. So talk amongst yourselves.
Oh, well, flat piece with the bottom first.
Okay, everyone, let's come back together. Okay, did anyone's predictions change from before? Nobody's, oh, Jayla, your prediction changed?
Yeah, I think I'm gonna say what Mina said.
And what was that option again? What do you think will happen?
That the clay ball will actually hit the bottom first.
Okay, does anyone else's prediction change? Alright,
No.
so now I'll do the experiment. I want you to watch closely and see what happens. What did you see?
Oh. I see that the clay ball hit first, so Jayla and I are right.
The clay ball did hit first. Does anyone know why it did?
Well, kind of like, like a parachute, like the clay flat piece kind of was like a parachute and it caught all the water and it just took a long time for it to get down.
Does anyone else have any other ideas why the ball hit first?
Well, it kind of like it reminded me of like when you cannonball in the pool and then when you belly flop in the pool. When you cannonball, you go to the bottom really quick.
That is an excellent example, Carlos. The ball is actually, it's smaller and the shape is different than the flat piece. The ball goes through the water faster because there's less friction than the flat piece. If you think of like a dolphin's nose, it's similar shape to the clay ball. Dolphin's able to swim through the water faster and cut through the water because there's less friction on that shape than the flat piece. Besides Carlos's example, does anyone else have any other ideas or examples that that theory would work with? Any other animals or
Well, what about almost any type of fish? Oh, wait. No, I got one. What about a penguin?
a penguin does swim through the water fast. Their beak is a similar shape to a dolphin, that's true.
You could also think of a beluga whale, for they are round as well, and they can go through the water really fast too.
All right, so based off what we learned today, Will, did you want to say something?
Oh, I was gonna say that frogs kind of look like little balls in the water, and they are really fast in the water.
Frogs are able to swim fast. I think not as fast as a dolphin because of the shape of their nose, similar to the ball.
Yeah.
But based off what we learned today, can anyone tell me in their own words what the lesson was? Jayla?
Yeah. So the lesson was that if something's going through water, if it is like a ball shape, it's going to go through water a lot quicker than if it's really flat.
Perfectly said, thank you.
And that's it for our lesson, and I hope you guys have a great day.
All right, stop simulation. All
I
right.
don't like how I did that.
So you don't like how you did that or
No,
not?
I liked my, when we did it in class.
You liked when you did it in
Yeah.
class? Oh, no.
It'll be fine.
I thought you did a good job.
Really?
Yeah.
Okay, as long as you
I
think
think
so.
so.
'Cause I felt like I could have done way better.
Let's do this. Well, maybe if we have time, we can try it again.
No, it's
No,
okay.
no, it's okay.
One is good.
All right.
Okay,
Do you guys
I
want
wanna-
us to record you?
Oh, yeah. Are you ready?
So ready.
Okay. All right. Start simulation.
Good afternoon, students. My name is Miss Kate.
And I'm Miss Guido.
And today we have a fun experiment prepared. We have two pieces of clay, and they both have the same mass, except one is rounded, and then the other one is flat.
So today, we are gonna do an experiment where we predict which piece of clay is gonna fall to the bottom of this jar of water faster. So,
We have three different options. I want you guys to listen to the options first, and then we're going to talk about what you guys think will happen first. So, do we think that both of these pieces of clay are going to land at the bottom together? Will the round piece fall first, or will the flat piece fall first? Okay, so does anybody think that both pieces are going to land at the bottom at the same time? Okay, Mina, why do you think they're going to land at the bottom at the same time?
Well, you said that they have the same mass, so that means that gravity is going to pull them down the same
prediction.
That was very smart.
Will, do you have one too?
Oh, I was gonna say the same thing that Mina said.
Awesome. Okay, is there anybody who thinks that the ball will hit the bottom first?
Okay, Jayla, why do you think the ball will hit the bottom first?
I don't know, I just do.
Okay, well, I guess we'll wait and see what happens, and maybe once you see it, you'll be able to come up with some hypothesis. Emily, why do you think the ball will fall first?
I think that the ball will fall first because, if you throw like pennies in a like a wishing fountain, it takes a really long time for them to get to the bottom.
That is a really, really good comparison, because the pennies and the shape of clay are the same shape. So it's very smart.
Now, does anybody think that the flat piece is gonna hit the bottom of the water first? Carlos, why do you think the flat piece is gonna fall first?
I think the flat piece is gonna fall first because, I think it's thinner.
It's thinner. Okay, that's a great prediction. So I want you guys to talk in groups, and I want you to think about what you guys thought, and then we're gonna come back together and see if you guys can come up with a consensus together as a group. So Mina and Will, if you wanna work together, and Jayla, Emily, and Carlos.
All right, everyone, let's wrap up our conversations now, and I'll come back together. Now, I want us to take a poll, or actually, sorry, excuse me, we already took the poll. I want us to take a minute and think about what we talked about with our groups. Did anybody change their mind about what their prediction is?
You guys all kept the same answers?
Yes.
All right, so now we're gonna test it out, and we're gonna see what we come up with.
Very cool. So I have the round piece in this hand and the flat piece in this hand. Ready? A mess. Did everybody see what happened?
Yeah.
Did somebody say no, they didn't?
No, I saw it.
Do you want me to try it again?
No.
Okay. Now, what happened? What happened? Which of our predictions was correct?
Ours was correct.
And what was yours prediction again?
That the ball would fall to the bottom before the thinner piece.
Very good. So now that we found out that the ball will actually fall faster than the thinner piece, why do we think that'll happen? That happened. Will, what do you think?
I'm not sure because you said that they were the same mass. Are they the same mass?
They are the same mass. We measured them beforehand and they're the exact same mass. So what's different about these two pieces of clay that might change the way they fall, like the rate at which they fall? What's different about them?
Well, one is thinner and one is shaped like a ball, but if they're the same mass, I'm confused.
Okay, that's a totally reasonable thing to be confused about. So, the shape, do we think the shape, because this one's more spread out, and then this one is a little bit smaller and denser, might have had something to do with it? Remember how I think it was Emily said if we drop pennies into a fountain, it takes a really long time to fall down? Yeah, well, what happens is because the ball is rounder and it's smoother, it's able to fall through the water with less resistance. So the water makes it easier for it to fall through, unlike this flat piece, which kind of floats down. Did you see how it floated down? That's because the water gave it a little more resistance because it's more spread out. Does that make more sense?
Okay, so let's make a real life connection, and maybe that'll help you guys understand a little bit better. So we're going to say that the round piece of clay is a bottlenose dolphin. Now, bottlenose dolphins have really smooth noses, and they're able to go through the water super easily because their noses are rounder and it breaks through the friction of the water. Now, this flat piece, we can kind of compare it to a penny. So the penny would still move slower through the water because it's flatter and it takes more time to get to the bottom because it's not as smooth and it's taking up more space. Does that help? Is anybody still confused?
Yeah, that makes sense.
Okay, I have one more question for you. Yes?
So is it like on a boat, how the front of the boat is all like smooth and round, but like the paddles are like really like flat so you can pick up water?
That's a perfect example. The paddles of a boat are flat, so we need to use it, and we need to use more force in order to get the water by because it's flat. But the front of the boat, because it's pointy, it gets us through the water a little bit quicker.
Cool.
It's a really good connection, Carlos. Now, can somebody just summarize for us what we learned today? Wow, so many smart hands. Mina, why don't you summarize it for us?
Okay, so even though two pieces of clay might have the same mass because they're in water, gravity doesn't work on them the same way. So, like the thinner, like if it's a ball, then it'll fall faster. If it's like a rounded shape, but if it's a flat shape, it might take some time.
Will, do you want to explain as well what you think and add on to what Mina said?
I think she said it all.
All right, great job, guys. I think we understand the difference and why the round ball fell before the flat piece. So you guys did amazing today. Good job.
Great job, everyone.
All right, stop simulation.
They're very smart.
So I just have a quick question for you. How might you have convinced them that the two pieces of clay were the same mass?
We could have like measured it in front of them.
Yeah.
To
Okay,
begin with.
right, we had the pan balance, you could have put it there and showed it to them.
Yeah.
And you might have pulled out a little bit more. I have two pieces of clay, can you see the difference? How are they different, or describe them? Even though you had different colors, perhaps they, they would come up and say, oh, one is rounded and one is
Yeah.
flat. Right.
Okay.
Sounds good. Anything else that you would have done differently if you had the opportunity to do it again?
I feel like just the way I always explain like why the rounded falls faster than this. Like I
Yeah.
wish I could explain it better.
I was trying to think of another animal
That
that
like
like
had
had
a
fun. And I was like, oh my god,
Yeah.
oh my god, oh my god.
Picture
I'm
your
literally
dolphin.
comparing an animal to a penny. Like this sounded ridiculous.
Uh-huh.
But like I honestly cannot think of another animal on the spot that would just like fall. Or like not move as fast.
Like cut through
If it
the
didn't
water.
think of- Cause I was gonna say like turtle.
Like an orca? How about a whale?
Turtles are pretty fast.
Yeah,
I couldn't think of something that was gonna move slow in the water, or like, I feel like everything moves fast in the water.
Have you ever seen like the flounders or the really flat
Yeah,
fish that they
that
might
would
have
be
like
fun, yeah.
float around or
That would
something?
have been a good one.
Yeah, all right, well, next time.
Yeah.
I feel like I could have explained it better. I felt like I kept like stumbling over words, kind
Yeah.
of, and I didn't, it didn't sound as clear as I wanted it
Yeah.
to, so I don't know if it's because I don't know.
nervous.
Also felt like I wish I had more energy when presenting it. I feel like I could have been more upbeat and everything, so.
Okay, so, these are all things to consider. Do you think you would try this experiment when you're in student teaching?
Like this one? Yeah, oh yeah.
Yeah.
Now that you have it down pat.
Yeah.
For sure.
And I feel like real students would help. Because like sometimes they just shout out answers too.
Right,
Like that,
Right.
really, I was super impressed when she was like, oh, like a penny, that
Yeah.
falls down.
Yeah.
I was like, I was not expecting that.
Carlos's Yeah.
answers for both of ours.
Yeah.
You like
Very-
came up with really good examples.
Yeah.
Better examples than we.
And sometimes they've come up with, what happens if it's like a torpedo shape? Or what happens if,
Yeah.
you remember, I think
Yeah.
somebody made it into a cube, or, obviously the children are going to be different
Yeah.
every time.
Yeah.
So, was this experience valuable for you?
Yeah.
Yeah.
I think
Even doing it
more
again.
experience we can get is like
Yeah.
the better.
Right,
Honestly.
right.
It's the fact that they talk like real students,
Yeah.
and that's literally what students would say in a classroom, so I feel like that's more, and you can see all of them, so like you can work also on like classroom management skills too, like if they're falling off task, like you can figure out different ways to get their attention back, so I feel like it's really
Right, and remember, we were looking at 3 things. We were looking at, fidelity to the model, how closely you followed the model, and you all did a really good job with that in terms of providing the options, and then having them engage in that peer discourse, and then seeing if they could convince each other of a different answer, actually doing the experiment, and then summarizing with why that happens. And I thought you all did a really good job with that. The questioning, for the most part, I think you really, ask those probing questions. What do you think? Why did you say
I
that?
had a question. It was my favorite question when I did the first one, and I wanted to do it again. It's like what if they can find a discrepancy between like by us putting the dropping it in the water by hand rather than like making sure like it's done like
it's like the
yeah
Right,
like
exactly,
making sure it's
it's
level
level,
like
yeah.
you're dropping both of them
Right.
literally at the same exact moment, like seeing if they can figure out what the discrepancy is and like come up with that answer.
Right, there were a couple of times when it wasn't dropped at the same time. They said, you didn't drop it at the same time, or you could, hold it and say 3, 2, 1, and then just do it. Also, you think about it, the ball and the disc, where's the bottom of it? Where are you holding it in? Are you thinking of it as like in the middle of it? Or are we doing it like this? Or kind of like that? Yeah. Okay. Fortunately, the play ball got to the bottom really much faster, and
I felt like watching them, I don't know, maybe because it was like a different view, but I felt like your lap piece took that time
Yeah.
to get to the bottom, but like I felt like ours was like
ours is
kind
pretty
of like
good.
right
Yeah,
after.
maybe because yours guys is a little thicker.
yeah, and obviously the mass is bigger on your pieces of clay than theirs.
Yeah.
But it was very clear that the ball
Yeah.
hit first. Just one other thing I would say is that density is a property of matter, and they both have the same density. The shape is different. They're all both pretty smooth, so
Yeah.
that doesn't change, but it's all about shape and that resistance in the water. All right. The other 2 things we were looking at, the last thing was engagement. And clearly you had all the kids engaged, the one time when Emily wasn't paying attention, you were right there. We didn't get Will drumming this time. We didn't get- So definitely there was an improvement, yeah. And, all right, so we had all the sticky notes. So we'll put them up on the papers, okay? Positive on the left, negative on the right. Remember, we were looking for evidence of those elements. Positive on the left.
Me too. Guys, you're so nice to each other. Oh.
This is a good question. It's kind of,
That's what I was gonna say. I don't know. Yeah, that's really frustrating stuff.
this is fun.
That's a really question, isn't it?
I don't know, should I put this here?
Yeah.
All right.
I can make up some negatives if you want. Just
That's okay.
go along with them.
If you were gonna make up some negatives, what would they be? think the area where I saw possible, most improvement was in the question.
Yeah, that's what I was asking, the question, like, just, like, I know I struggle with making questions and
Yeah.
like, making sure they're open-ended and like,
Yeah.
thought-provoking and like, just making them good questions,
Mhm.
and so like, I know I could for sure work on that.
Yeah.
I think it could have been more clear in my explanation. I felt like I was going in a little bit of a circle, but maybe getting like directly to the point faster or in a simpler way, I guess.
I feel like being more on top of like when they, say those answers like with the penguin and the frog and everything, like I feel like we were kind of unsure of how to like
Yeah.
answer that, if that would work. But I think they did a pretty good job for the most part, but.
Yeah, the one thing I always see is, do you think, or who, there's a way that it's phrased sometimes, which
Yeah.
could be answered yes, no,
Yeah.
but they didn't take it that way, When you're unsure, you can always just say, why do you think that? Can you explain your thinking? So, what?
Dive further into it.
Dive further into it. So yeah, when you're doing these science lessons, it's really critical to understand the basic principles and concepts behind it.
Yeah.
Certainly doing it second time around is better.
Yeah.
I think that helps.
A lot.
That's why there's no negative. We did it twice.
Right. Great job. So, they stopped it, because we had till 1 o'clock. So, anything else you want to say about this?
I like that we've gotten into it 3 times.
Yeah.
now. Like we get more used to it each time.
Right.
Yeah.
Right.
I wasn't
Which
as
is nice.
nervous this time
Yeah.
around because I expected what to see in front of me. I knew who the students were.
I knew the lesson already.
Yeah.
Right, right. And you'd already seen it like 3 or 4 times, you did it yourselves, you
Yeah.
watched your peers. So, cycling back to last semester when you did the fraction lesson, how was that?
It was a harder lesson, I feel like, but I liked it. I don't know. It was different.
Yeah.
It wasn't like an experiment. We had like the materials in front of us too, but I don't know, it was more
It was like teaching
more
an actual
content-based,
lesson.
yeah.
Yeah.
This didn't feel like teaching an
It
actual
felt like
lesson?
teaching an actual lesson, but like this one, I felt like we had to start from scratch, and all we had was like the manipulatives and like what we were saying as like our factual information. But like they were like able to see, and then like if we were to put it in a real classroom, like those things are tangible to them, and they can do it and they can see it for themselves, like in a group and talk about what's going on. And I feel like the fraction one, it was more of like there's like no peer interaction, I guess you could, like there's like less interaction with your peers because it's like either yes or no, you kind of get it or you don't. Rather than like this one, you can like come up with predictions and like have somebody convince
They
you,
were more
like,
involved.
yeah.
Right,
This is
right,
more
yeah.
engaging.
Yeah, well, certainly, I think it was probably easier having the full lesson
Yeah.
that you had to follow, and then with the other one, you were just given the problem. Or,
Yeah.
the numbers, and you had to come up with a
Figure it out.
problem and then really develop the whole lesson.
I think also with fraction, there's a lot of, like myths about fractions.
Yeah.
Like looking at 5/8 and looking at 2/3, like 5/8 just looks bigger. And like you have to try and get that out of their head, so they're already coming in with like preconceived notions about that. But like
Mhm.
here, you're asking them what their preconceived notion is, not trying to get it like out
Not
of
trying
their
to
head.
change it.
Yeah, yeah. Well, I think both of the models really focus in on trying to address any alternative conceptions and, guide your learners so that they are coming up with the appropriate explanation.
I also felt like it took me out of my comfort zone too, because I'm not, I'm not a math student or a science major,
Yeah.
so it's kind of teaching me something as well and how to explain it in something that I'm not used to explaining, so I felt like that was
But
really
it's like so
helpful.
good. I feel better now that I have the experience of teaching this lesson twice in science and even the fraction lesson, at least doing that. So like when I go into an actual class and have to like teach math and science lessons, I'm like, okay, I kind of know what I'm doing. Like we've done this before, not just like something completely out of the blue where I'm like, I have no idea what I'm doing now. Yeah.
Yeah. But like here, I feel like I can give like a really good, like even come up with like my own lesson plan and like adjust it to how like I would do it in a classroom and then like actually like do it in a classroom and look like I know what I'm talking about. Act the part.
That's it. You know, fake it till you make it, they say.